everybody, welcome back. This video is kind of building on our last video where before we defined the word force, we're going to look at some common forces because there are a lot of forces we experience or you might notice on a problem or a scenario that are so common scientists give names to them. Also, we're going to look at something known as a free body diagram, kind of a big set of words that simply represents how do we draw forces acting on an object. That's it. That's our video. Go over some common types of forces and then learn how we can draw to show how and in what direction forces act on an object, okay? I'm just kind of going to have this list then. We're going to run through these items. I certainly recommend you take notes. Taking notes helps you internalize because you taking notes really forces you to listen, to process what's being said, and then if you're writing it down, make sure that you understand what's being said. Now, certainly you have access to resources and you could look up the definitions of these if you forget in the future. Maybe your teacher will have resources for these. It's not the most important thing if you jot down every little thing, but as always, writing notes is helpful if you're really trying to understand this material, okay? So first, force. That's what we're going to do. We're going to run down some types of forces, all right? The first one we actually already learned from the last video, so I'm not going to go over. I'm not going to spend too much time on it. It's known as weight. It's given the symbol W. It has to do with the Earth in our case, or any large object. When it's pulling something down, we call that weight. Now, weight has an equation. The weight of an object is equal to its mass multiplied by g, where mass is measured in kilograms, and g is this 9.8, but that's weight, okay? Another force is a little weird, okay? Right now, you are maybe sitting on a chair. Well, let's think about that. If we're sitting on a chair and we know there's a weight force that pulls us down, how come you're not falling onto the floor right now? Or how come you're not like crashing through your building and the dirt and the earth? Well, your chair is supporting you. If you look at my webcam, your chair is kind of going like this. It's holding you up. If you're standing on a floor, the floor is supporting you. Yes, there's a weight force because of planet Earth pulling you down, but the surface, whether it's a chair or the ground or grass outside or a cement block, it is supporting you. We call this force a support force. It's usually an upward force acting on an object when that object, whether it's you or your computer or your keyboard, when it's resting on a surface. Here's another good example. A textbook resting on the table, yeah, the book feels a downward force due to weight, but the table is supporting it, hence support force. Real quick, team, support force is also known as the normal force. This is a little bit more of the technical definition. I won't get into why. You could Google it if you care. You might hear me say normal force. You might see this in certain books or online resources, but they're the same thing, okay? It's the force that's coming from the ground or some surface that is supporting an object, usually or at least often balancing the weight of an object, okay? Team, next thing, friction. Friction is a word, and maybe you already recognize that it's a type of force, but it's a word that you're familiar with. There's actually going to be another video in the future that goes into more detail with friction. Just a couple basic things. Friction, it's a force that is basically always opposing when things are sliding. If you take your two hands and you rub them together, maybe you feel your hands heat up a little bit. Your hands are resisting this sliding. You're feeling friction. Put your hand on your table and try to slide it across the table as you're pressing down. You are feeling resistance. You are feeling friction. I'm going to hit a keystroke and a couple of images are going to pop up. This is just how we might show the weight acting on an object right here. Here's a diagram showing friction. If I have a block on a table, or maybe it's this book again. If I'm pushing this book to the right, friction opposes. It doesn't like it, resists that motion. Friction is often acting in opposition, often opposing, okay? Again, there's another video that we're going to see in the future that goes a little bit more in detail with friction, okay? Air resistance. We're actually about halfway done with this video, team, at least in terms of the different types of forces. Air resistance is actually very similar to friction. It's something that often is resisting the motion of something. That's why skydivers use parachutes, because the air can apply a type of friction. It can resist the motion. You could even just hold your hand up and blow into your hand, you can tell that air particles can apply forces. And if you're moving your hand through the air, or if you're driving down the road and you stick your hand out the window, or you go skydiving and you use a parachute, you can use that air as resistance, or you can at least feel that air as resistance. That's what we call air resistance. To be honest, team, a lot of times in our class, we're going to ignore air resistance. While it's all around us, we can't really avoid it. For most small things, unless it's like a parachute, for most small things, air resistance is pretty small. It's also difficult to measure the air resistance. So in a lot of problems and even labs that we do, we'll often just like pretend there's no air resistance. And while that's a simplification, it's not a terrible one, and it makes our lives a little easier. So it's actually often a force that we're going to ignore. Air resistance is also called drag, so you might have heard or you might see that word in the future. Again, it's something that opposes the direction of motion. An airplane that's flying in the air, it certainly has a weight force. It uses air in its wings to help create something known as lift. The propeller pushes or allows the plane to move through the air, but based on the shape, when the air hits this plane, some drag or some air resistance is created, okay? Team, I just got a couple more forces. The next one is tension, and this is a very broad name for forces that are coming from things like, think about a string or a rope or a cable or a chain. I like to call these things like little danglers. I'm holding up a shoelace. I'm not sure how well you can see, but things that are of this nature. Imagine I was holding up like a necklace or a piece of rope, okay, or even a heavier chain link, all right? Things that dangle while you are usually using these objects to pull on objects because these are pretty common things. These different materials right here, they are usually labeled as tension forces, okay? When you are pulling on somebody with a rope, you might see it labeled as a tension force. Yeah, you're pulling on the other person, but you're using tension in order to do that. Or here I have a wrecking ball. The wrecking ball is holding up, or the machine is holding up this wrecking ball using maybe a really heavy rope or chain. You might say that this ball is being held up by a force of tension. Okay? Also, if you are pulling something at a diagonal, again with a rope, all right, you're pulling with tension. Right here, it says that the tension, the direction this force acts, it's kind of easy. The trick is it's in the same direction as the string or the rope. It looks like this girl is pulling on this other girl in this tug of war by pulling on the rope. What direction is the force on this person? Well, since the rope is horizontal, the force is horizontal to the left. Here, the tension force, because the string is vertical, the tension force on this ball is vertically upwards. Here, if this was a string and we were pulling it at some angle, the direction of tension would also be at an angle. Okay? The last name is almost like the most generic thing I can come up with. There are so many types and examples of forces, team. They don't all have a name. You do not have to worry about naming every little force. What I just showed you were forces that are just so common. Scientists tend to slap a name on it so people know what they're talking about. But each of these pictures represents different examples of forces, different examples of pushing or pulling. You don't need to know, and in fact there aren't specific names for each of these. You could call them what you want. You could call this simply pulling force. You could call this shoving force, or maybe just the applied force. You could call this kicking force, or foot force, or just hitting force. It doesn't really matter. What's usually important is that you are labeling, it's clear what you're referring to. So don't worry, not every force needs its own name. As long as you understand kind of like the origin of the force, that's probably fine. Okay? Last chunk for this video, team. We're over halfway done with the whole video now, okay? We've gone over some common forces. The last thing I want to talk about is how do we visually represent when a force or when forces are acting on objects? And there's a convention, there's a standard way we do that in physics. It's known as, the tool we use is known as a free body diagram. Scientists are lazy. Instead of writing this whole thing out, we often write it as FBD. So free body diagrams are also known as FBDs. You might see either myself or other resources call them force diagrams. Same thing, but this is technically the phrase, and you might see that in online resources or textbooks, okay? So how do we represent the forces acting on this box? Let's learn what this is by just doing an example, okay? I want to think about the forces acting on this box. This box, we're going to say, is on ice. I say that because let's ignore friction. No friction, let's pretend like there's no air resistance. But it is sitting on this ice. We're on planet Earth, and it looks like this person is pushing on the box to the right. So how do I represent the forces? The first thing, team, and I'm really grateful for this step number one. The first thing we do is we draw a dot. The dot represents the object. And I'm grateful, team, because I am not an artist. I can't draw very well. So if I was trying to represent the forces on this box, the first thing I would do is freak out because I'm like, I can't draw this. Or let's say we were trying to look at the forces on a car. I can't draw that. Or a cow, or a tree. All right, so instead of trying to draw the object, we're just going to draw the dot. This is representing the object. And boy, that's so much easier to do either on slides or just with your pencil on your paper. You draw a dot. This dot represents the object. In this case, I care about the forces on the box. So the dot represents the box in this example, okay? Let's think. What forces do you think are acting on this box? Well, team, one of them is easy. If we're on planet Earth, we know that Earth is always pulling downward on things. There is a downward force on this box. Do you know the name of this force? This is gravity, or weight. This force right here is representing the weight or the force of gravity on the object. That's what this downward arrow is. This is one force on this crate, okay? Can you think of any other forces that are acting on this crate, on this box? Well, team, if this person is pushing on the box, it seems like it's being shoved to the right. What would I call this? You could call it pushing force. You could call it applied force. Remember when I said not all forces have names? But there is some force that's being applied on this box acting to the right. And so the dot represents the box. Notice, I kind of start where the dot is and I draw an arrow pointing in the direction of the force. This person is pushing to the right, so the arrow points to the right. Earth pulls down, so I start on the dot. With my pencil, I would draw downward, make an arrow, because the gravitational force is downward. Any other forces? I'll give you a hint. There's one more. If we're on planet Earth, we know there's weight, but the box isn't falling downward. It's not crashing through the ice. It's not crashing through the ground and going into the core of the Earth. So what force does there have to be that's supporting this crate? It's the support force. Remember that thing that is holding you up, like your chair right now, or maybe the floor? The ice itself is supporting the box. This is known as the support or the normal force. And since it's supporting, it's applying a force upward, we draw an arrow pointing upward. Okay? In this example, that's it. These are the three forces acting on this box if we're ignoring friction and we're ignoring air resistance. And again, those are two things that we often ignore to keep our lives simple. If you're not sure if you should ignore that, you should always ask like the teacher or whoever is asking you to do whatever problems you might be working on, okay? But that's how we represent forces acting on objects. Again, I hope you took notes. It really helps you learn and remember this material. If you're in my own class, I will likely give you a resource that has the core idea, so you don't have to memorize every little bit. The paper that I have historically also has another example of drawing these free body diagrams or these force diagrams, and it gives you instructions. But depending on the class or where you're coming from, hopefully you'll get practice on these objects, okay? So that was me listing a variety of forces and how we represent forces acting on objects. Thanks a lot for watching. See you next time.